So my name is Felipe, and I'll be your host for today's webinar, especially focused to bring you what's new on ScyllaDB. And as you know, ScyllaDB has a very fast development cycle, and we do understand that sometimes it may be very hard to catch up on every single new feature we announce in short periods of time. And today's webinar basically aims to address that. So whether you are using ScyllaDB already, or if you are curious on how ScyllaDB is different compared to other databases, we hope you will find today's content interesting. All right? But before we actually start discussing about those new features, let me quickly give you an overview of what ScyllaDB is. And ScyllaDB is the database for predictable performance at scale. We are behind the most critical and performance-sensitive workloads in the world, and we power organizations to deliver extremely aggressive response times within a budget. So what do we mean by predictable performance at scale? That's a great question. So by predictability, we mean a database that scales linearly and keeps up with performance no matter you add 2x, 4x, or even 10x your existing deployment. This simplifies TCO, and we take linear performance very seriously so that you maximize your investments when you are using a database like ScyllaDB. And what do we mean by performance? Well, we mean a database that can just run as fast as a cache with latency well below 1 millisecond when data is entirely served from memory. And what do we mean by at scale? Well, being able to sustain your workloads no matter what scale you're at. Like Discord, for example, which migrated from Cassandra to ScyllaDB to store trillions of messages with 60% infrastructure savings and while still improving their latencies. All right. So in addition to Discord, of course, here's a small listing of ScyllaDB users. Epic Games, EA Games from the gaming industry, Comcast, Hulu, Disney Plus Hotstar for mid-streaming, Expedia, Zillow for retail and personalization features. What I want to call for your attention, though, and I think it greatly exemplifies ScyllaDB's capabilities, is this second logo you see over here, Blue Sky. So in case you guys don't know, me and Lucas, we live in Brazil. And an interesting story happened because we no longer have access to Twitter. And basically what happened is that the entire country, all Brazilians, migrated to Blue Sky, like that, in a single day or two. And it happens that Blue Sky is using ScyllaDB under the hood. So ScyllaDB is the database to support you, even if a country, an entire country, starts using your services like that. In a blink of the eye. Yeah, looks.
If you allow me to hang in, because I don't know about you, but I was a heavy user of Twitter, X, and so now we have basically all Brazilians moved to Blue Sky. Just to give an idea, for since in the last blog that they published in September, they had an increase of 2.6 million of users in a very short period of time, and 80% of these users came from Brazil, obviously. So what is impressive and what we want to highlight here is that since they are running Scylla, they did have some application tweaks that they need to do, but the database itself held it and was able to deliver with exactly the same performance they had before. So this is something that we are very proud of.
Yeah, no, definitely. Thanks, Lucas. That's very good. And I was checking yesterday on Blue Sky. I think they now reached 10 million users. But I think that's super recent news. But that's good information. But all that said, I mean, guys, a quick intro about ourselves. I'm Felipe Mendes, a technical director at ScyllaDB. I'm also one of the co-authors for Database Performance at Scale. And Lucas also helped to review this book before we published it. So thank you so much, Lucas. And why don't you simply go ahead and also introduce yourself, please?
Okay, so my name is Lucas. I consider myself an enthusiast between, one of the things I like is, handling with all our customers and, all the cases that we have. But at the same time, I really like to go deep down into the technical sides, and that's why I work with Felipe for so many years. And I'm still mad at Felipe that he didn't add the tag puppy lover in my description. And I requested so many times. But other than that, we've been working together for quite a while. I've worked here at Scylla as a customer success manager. So I manage basically the accounts that we have here at Scylla. And not only that, understanding, the needs of the customers, what we can deliver, and making sure that everything is done in the most efficient way. And also, more from time to time, I do provide a role of a trusted advisor to our customers. And so that's why this particular topic in this webinar interests me so much.
Yeah, no. Hopefully, I will be able to teach you something you already know a lot. And yeah, with regards to the puppy lover thing, maybe we can switch it. Do you play guitar? Because I don't have my guitar, so maybe I should just
Nah,
switch over. Yeah, I give you the puppy lover and I take the guitar.
I'm a one-trick
Yeah.
pony on that front.
All right. So here's a quick overview of what Lucas and I prepared to discuss today. So first, of course, let's discuss the new ScyllaDB capabilities and provide you what you need to know about them. How to use it, recommended settings, things you should be aware of before you actually start using those features, and also as feasible and as time permits, demonstrate how they work in practice. Then, after we bring you up to speed, we are going to cover some of our newer ScyllaDB Enterprise and exclusive features. And before they actually get started, I just want to give you a quick reminder. We unfortunately don't have time here to cover every single new feature ScyllaDB introduced in a short period of time. But we believe we are covering the major changes here. And in case we have not, pardon in advance. All right? So let's get started with what's new in ScyllaDB. And here's a question to you, Lucas. Do you have any idea what's the first feature which we are going to be talking about today?
Well, yes, I do. I'm very eager to not talk about, but to hear about tablets. So go ahead.
Yeah, let's see if you're right. Oh, tablets. Yeah, so you're definitely right.
What
So
a
you guessed it
surprise.
right. Yeah, what a surprise. So tablets are definitely the major announcement available starting from ScyllaDB 6.0 and which is also coming in our upcoming ScyllaDB Enterprise release. So what are tablets and why do we need them? Why ScyllaDB decided to change a big portion of its internal replication architecture? So tablets are basically part of a multi-year project to bring elasticity to ScyllaDB. In a nutshell, what it does, and you can take a look at the video to get a feeling of how it works, is that tablets basically split the data in your tables into smaller logical pieces, which are called tablets. And those tablets, they are dynamically balanced across your cluster with the help of the Raft consensus protocol. And we are going to be talking about Raft shortly, but it's still on tablets because tablets allow ScyllaDB to shift from a static to a dynamic partitioning schema. This results in faster topology changes and seamless downscaling. And you may wonder, why do I need this? I mean, why scaling fast is important? And Lucas, since you work very closely with our existing customers, I'd like to get your perspective on this.
Yeah, one of the strong points of Scylla was always scalability, and that's something that hasn't changed. But as the way the Scylla works and its architecture, whenever you need to add or remove nodes, you had to do on in a rolling manner, one at a time. So basically, we're adding one node at a time, adding a node, streaming the data, checking, making sure everything is okay, and repeating the process all over again. Obviously, if you're adding a lot of nodes, the less nodes are going to take less time because there's less data to be streamed, but that still required some time, and we want to be even faster. So with tablets, what we can do now, and Felipe is going to explain the whole technical aspect of it, but since now we can basically get chunks or tablets, as the name says, and move the data directly, we can add multiple nodes in a particular time either adding or removing. So that makes this scalability process a lot more fast, a lot faster, but it's still as reliable as it was before.
Yeah, yeah. No, no, that's a very good point. So yeah, I mean, let's just jump straight up writing because I did prepare a bit of work for us. Let me see if I can find my terminal. And there it is, a bit out of order, but yeah, I guess it happens. So Lucas, do let me know if you can see my screen. And what I have done is
Oh
I
yeah.
pretty much already started monitoring and 3 nodes. Okay, so nothing extraordinary, just 3 nodes, 3 node cluster. Can you see it? And I'm highlighting right now. Okay, thanks. And but actually, before I start to show you things, I do want to give the audience a quick reminder. So the first thing you should know about tablets is that as of ScyllaDB 6.1, which is our latest open source release, tablets are currently not supported for tables containing counters, change data capture, lightweight transactions, and ScyllaDB Alternator, our DynamoDB compatible API, because Alternator relies on lightweight transactions under the hood. All right, and we are working really hard on supporting those features, but should you have a hard dependency on them, you won't be able to use tablets as of now. And you can still use ScyllaDB because we still support the older, now legacy partitioning schema. All right, and the second important thing you want to know before you get started with tablets is always remember to update your monitoring stack. Okay, so the latest ScyllaDB monitoring contains those panels here, tablets, and as you guys can see, there is no data because we haven't created anything, but you do want to be able to see those panels so you can monitor how tablets are doing in your cluster. And as we are going to see, they are super cool. All right, so all that said, let's get started. And the first thing I'm going to do is to log into our first node, which is called node 1. And I'm going to run node 2 status, which is basically is going to show us that we have a 3 node cluster. So far, so good. All right. And one of the things that I really like to do, Lucas, is I typically like to run Scylla -- help and then pipe less so I can get a pager. And from here, what I'm going to do is basically I'm going to search for tablets. And this is basically going to show us that, actually, I think my zone is too big. Yeah. We have 3 new configurable options for tablets. And here's what you need to know about those options, starting from the bottom up, all right? So the first option is called enable tablets. And as the name implies, when this option basically indicates whether tablets will be enabled or not when you create a new key space. So keep in mind that by default, starting on ScyllaDB 6.0, tablets are enabled by default. But you don't need to update this configuration parameter should you not be willingly to use tablets. As we are going to see, you can, when you create a key space, you will be able to say, hey, I want this key space to use tablets or not, all right? The second parameter, the second option, which we introduced is this one, target tablet size in bytes. And remember what me and Lucas explained earlier, that with tablets, basically your table will be split into smaller pieces. And that configuration option, target tablet size in bytes, is precisely the option which indicates how large those smaller pieces will be. By default, 5 gigabytes is what we found out to be the best trade-off, and we don't recommend you change this option unless you know what you are doing. But you do have the option to change the size of a given tablet should you want. All right. And the third and final configuration option is this one, tablet's initial scale factor, which indicates the scale factor by which tablets will be scaled once it crosses the 5 gigabytes, the tablet size is specified earlier. And currently, the default is 1 or 100%. And what this means is that eventually, you typically create a table, and this table starts small with no data. Then you start ingesting, populating data into this table, and eventually your table will cross the 5 gigabyte boundary. And when that happens, ScyllaDB will automatically split your table again, create an additional tablets, and this process will require compaction, and it's effectively what we call a tablet split, all right? So, for example, with a setting of 100%, from one tablet, you will go to 2 tablets, and then if tablet splits happen again, you will go to 4 tablets, and so on. Yeah, go ahead, Lucas, sorry.
Felipe, one of the questions that the people watching might be asking is, you mentioned that we can enable, they're going to be enabled by default in this newest version. But do we need to have all key spaces and tables using tablets, or can I still use my CDC cases alongside tablet key spaces and tables?
That's a very good question. So let's actually do this. I mean, let's exactly address that question live. I don't know if it was actually asked by someone, but it's a good question nonetheless. So the first thing I want to do before we address this question is let's actually create a key space with tablets enabled, right? So nothing changed with regards to this sentence itself. So you can still create a key space as you are used to. So create key space, name of the key space with replication, and then you are going to specify your replication strategy. In this case, we are going to use network topology strategy because I know that's what Lucas typically recommends, right?
Exactly. That's the recommended, every time that you have a production environment and you're using, even if you're using a single data center, please use network topology strategy.
Yeah. And what we added was basically an extension to this command, which is called and tablets. And here you can specify whether you want tablets enabled or not. So in this case, as I said, let's create a key space with tablets enabled, so true. And here's an interesting option, which I don't know if it's documented, which is called initial, all right? And I'm going to specify 2 here, but let me provide you a context over what this option actually means. So if you already know how much data you are going to store in this key space in advance, then you can hint the database by how many tablets it should be creating in advance before you even start populating, ingesting your data. And why you may want to do that? Because remember what I said, that if you keep crossing the tablet threshold very often, ScyllaDB will start basically splitting, and by splitting, we will have compactions and so forth. So to prevent that, you can typically hint the database how many tablets you believe you will need on average. Simply multiply this number by 5 gigabytes, and then you will get to how many tablets you will need, all right? So a few warnings which are shown here. So as I said, if you do create a key space with tablets, you cannot use CDC, lightweight transactions, nor counter features. And we are working on that to provide support for those features along with tablets, all right? And this warning actually addresses the question, Lucas. So if you want to use CDC light rate transactions, or counters, you don't need to drop this key space. Maybe we should submit a pull request to change this message. But you can create another key space. Let's call it no tablets. You can see how creative I am. And instead of saying enable true here, you simply say enabled false. And done. You have a key space without tablets, and you can continue to use your CDC counters as you always use it here. All right? A few things that I want to call for your attention before we actually switch to talk more about additional features. Let's create a table in the tablets key space. So I just created a table here. And remember when we created our tablets key space, we specified initial two, all right? We hinted to the database that we wanted 2 tablets for each table created in this new key space. So let me go to the monitoring now. And as you guys can see, now we are starting to get metrics from the tablets panels in the ScyllaDB monitoring dashboard. And look what's cool. Each node in our cluster has precisely 2 tablets each. And as you guys may guess, if we create additional tables, each table will also have its own tablets. So for example, let me go back to the terminal. Let's create another table. I don't know, table 2. And if we go to our monitoring and we start a little bit, it's probably going to take a few seconds until it scrapes again or our Scylla endpoints. You are going to see that we are going to have 4 tablets per node. Yeah, and that's exactly what's happening over here. Yeah. So this is basically how tablets work. It's per table, and on top of being per table, it's also tablets are distributed by shard. All right. So if I switch the visualization on per shard, you can see that each shard on your cluster has exactly 2 tablets each. In this case, it's 1 tablet per table. All right. Although the distribution itself is done automatically by the database. So sometimes you may see like, hey, 1 shard has 1 additional tablet than other tables. So it depends on the internal database logic. So as you guys can see, we pretty much did nothing in the database automatically balanced things out for us.
I do have another question, a single one. As we're showing here, and it's great that we can see how the tablets are distributed, and you already established that we're going to have 2 tablets per table in this case. How does that affect the disk utilization monitoring for my cluster? So, from now on, it's either all or nothing with a tablet being filled, or is its size, or I still can see how much precise data I'm consuming in each disk or each particular node.
That's a good question. So your disk utilization doesn't change because tablets are in essence basically a logical abstraction, right? It's an internal database concept. So when you look into your disk utilization, either if you are using the monitoring or if you are using tools like the gf command, this won't change in any way how your disk utilization is represented currently. Does that addresses your question?
Yes, that's exactly. I already knew the answer, but I wanted to hear from you. And
yeah,
and we do have a question here that I wanna read out loud, if possible. Is that I hope I'm pronouncing that right, but Francor is asking how the data is distributed between tablets. Do they replace partitions?
That's a very good one. So yeah, let's actually show that. So I'm going to run this expand down command. I don't know if you ever use this expand down command. Lucas, it's a very interesting one when we want to show too much data. via SQL S8. And remember what I said, that tablets are a logical abstraction. So what I'm going to do is run select everything from system.tablets. And this is a system internal table which ScyllaDB created. And yeah, this is basically what the expand on command does. It makes it much easier for us to read the data instead of a columnar way we see it in a row via rows. But anyway, addressing the question, so tablets are basically split on token boundary, all right? So it doesn't change the way you write or read a partition from the database, but what ScyllaDB tablets effectively do is it gets your token ring and it basically starts dividing it equally and assigning tablets to each shard dynamically, all right? So for example, remember we created 2 tables. So we have here, for table 2, we have 1 tablet, and also for table 2, we have another tablet. And for table 1, table 1 is here, we have 1 tablet and then another tablet, and that's it, all right? Does that help? Good. All right, so a few other things you may be interested to know about tablets. I was going to add nodes here, but I see that just on tablets we already spent almost half an hour, which is half of our webinar, so I'm not going to add nodes. We did present, guys, a few months back, weeks back, a webinar where I have demonstrated live ScyllaDB scaling speeds while using tablet. So if you are interested in actually seeing how fast ScyllaDB scales up or scales down, please watch that webinar. But one of the things I want you to be aware of is that tablets basically eliminate the need for you to run language tasks, well, previously language tasks such as node tool cleanup. So if you are already a ScyllaDB user, or if you are a Cassandra user, then you know that every time after you scale out your topology, you have to run node tool cleanup, because effectively this will start clean up compactions so that the nodes will start evicting the data for the token ranges they no longer own. And because tablets are effectively, because as SS tables for a given tablet are always compacted together via a concept which we call as compaction groups, basically node to cleanup is a no-op operation. Basically what node to cleanup does is basically, boom, delete the SS tables which this node no longer owns. All right, and Lucas, is this something that actually helps you guys in the field?
And I was talking on mute. Yeah, definitely it does.
Cool. All right. So back to slides, and it's still on tablets, but really quick. What about drivers, right? Because tablets are really change the way data is distributed across the cluster. And as I have shown, we do have that system.tablets table, which basically stores all the information about tablets. One of the things that you need to know is that ScyllaDB drivers, they are already tablet aware, but they don't read from the system tablets table. And you may wonder why. And the reason is because, as you can imagine, that table over time, it will grow in size, especially if you have very dense tables. And the more tables you have, more entries will be collocated in that table. Plus the fact that tablets are dynamically allocated, right? So as your table grows, eventually more and more tablets will be created. So it will never make sense for a driver to actually constantly query that table. Instead, what we have done in our drivers was a flow like this, which we presented in our recent ScyllaDB summit, but I'll try to be brief here. So once you connect with tablet-aware driver to your cluster, your driver will send route queries to a random replica and shard. And if the driver routes that query to an incorrect node and shard, the query coordinator, the node and shard which received that query, will basically respond back to the driver with the correct information, with the correct node and shard, which actually is responsible for routing queries for that tablet. All right? And with that design, our drivers are basically able to dynamically update the route information, just like the database dynamically migrates tablets across replicas. All right. And if you are wondering which drivers currently support tablets, those are the ones here in this list. Things you should be aware of. If you don't use ScyllaDB drivers, if you use community or DataStax or other drivers, they will not have, of course, this optimization. And so we would recommend you to use ScyllaDB drivers. They will still work though. You are still able to connect and send queries just as you are used to, but you won't get the correct routing to the correct tablets because of this change. All right? Okay, so now let's talk about Raft. So what you really need to know about Raft is that tablets are Raft is the foundation for everything that's strongly consistent on ScyllaDB. So as I said, as Lucas and I were speaking, tablets are basically dynamically migrated across replicas. And you may wonder, hey, don't you guys have a risk of data loss? Of course not, because under the hood, we are using the Raft consensus protocol and read and write barriers to basically ensure that those migrations are done atomically. All right. But beyond just tablets, what else Raft help us with? As you know, schema changes starting, if I recall correctly, on ScyllaDB 5.2, Raft was basically made production ready for schema changes. And more recently, also for topology changes. In case you are wondering how ScyllaDB can add and remove multiple nodes in parallel, it's not only tablets. So Raft also ensure that those operations are carried out consistently across the replicas, and this is super important because you don't want to lose data, right? More recently, we also extended Raft for to bring you strongly consistent authentication updates. So you know when you create a new role, when you update a password, and also for service levels. In case you guys are an enterprise user and make use of workload prioritization, and if you are not, and you use workload characterization in ScyllaDB open source, those updates to those service levels are now done also atomically. And this is really cool because in the past, whenever you were going to add a node to your cluster, you would always need to, update the replication factor of the authentication key space. Then you would need to run repair. And this was really painful maintenance task. And that was also very prone to errors. And now that Raft manages everything, you can simply, create users and change passwords, and rest assured that Raft will basically manage everything under the hood for you. Does that help, Lucas? What's your perspective on those?
Yeah, I was just reading some comments here, and that was like the main concern. How can you
Mm-hmm.
guarantee that the data is going to be distributed? Do we have any loss?
Mm-hmm.
How does that change from
Mm-hmm.
the previous way the Scylla worked for now? I think you covered the basics, and we definitely can provide more documentation on that if needed be. But I think for now it's what we needed to know. Because every time there is a change, especially when we're talking about changing architecture, the main concern is things were working before. Why change? So, and is that any
Exactly.
better than
Mm-hmm.
before? So
No, it's
I think
definitely much better. Mm-hmm.
I think
But
that's the
it's a
key
good
point on this.
concern. Yeah, yeah. We did explain it how we do actually ensure correctness at several blogs and also talks already. So yeah, currently here we are really briefly walking you through the new features, and there are tons of information on how on the engineering side of things on how we actually did it, right? But yeah, Raft is basically the foundation for ensuring, although everything is done and carried out atomically, right? And
Yeah.
to address the question, how different it was. So before, ScyllaDB only relied on the typical token ring, right? And the problem with the token ring is that it was basically static. So whenever you had to add nodes, uh, as you said, Lucas, we would need to carry out those operations serially. It would take long, and after carrying out those operations, we would still need to run things like node to cleanup and then update authentication tables. So yeah, it wasn't ideal. But in our defense, it was something we inherited from Cassandra's design, right? So Cassandra still has those flaws. I believe they are working to address those. But either way, this webinar focus is on ScyllaDB features. So let's move on.
I would
Something,
just rephrase Felipe. I would say that it's not a problem that we had in the past. It's just an improvement in the way things worked. And I
yeah.
say that because there is a consistency and a meaning why that was said that way, as I said before, not only to be compatible with Cassandra, but also the token ring distribution and the way the data was flown, the Scylla token ring worked. But now,
Mhm.
since we're working in a more dynamic way, like I mentioned with Raft, it's very important for us to be able to accommodate those changes because that was an important part of the process. That was something easy to execute, but if forgotten, would cause a lot of trouble when we're scaling out.
Mhm. Exactly. Schema is commit log. So this is a feature which typically should be transparent to most of you, and it should require no user action nor intervention, but it's good for you guys to be aware of this new component and why we introduced it. So schema commit log. Um, so what happens, one of the things that we eventually found out is that whenever you are doing a schema change to database like ScyllaDB, this would require flushing the main tables of all tables in your cluster. And sometimes flushing main tables would, all main tables would basically cause, could be a very lengthy process. And eventually we sat down and we realized that, hey, why are we doing this? Well, basically, as I said, we inherited this design from Cassandra because after we realized that there is no need to flush main tables of all flush the main tables of all tables in the cluster, we basically decided to split the commit log from tables, user tables, commit log, and schema commit log. And due to correctness, this feature is also mandatory for Raft, all right? And I added all the pull requests and relevant issues with the motivation in this slide with the motivation of why we did that. But yeah, so now that's something which I think is super cool. because with this feature, we improved the time it takes for you to run a schema change in ScyllaDB by over 70%, which is like, wow, just by splitting commit log from user to schema commit log. All right. So goodbye, JMX. That's something I am really proud to finally announce. And let me provide you guys some bit of context here. So ScyllaDB historically shipped with slightly modified version of Cassandra JMX. And back then, it made sense because it allowed us to focus more on more important stuff like the database itself. But over time, we realized that JMX was slow, mainly because it's dependent on Java, right? And if you guys ever heard about ScyllaDB, saw about us posturing ScyllaDB, you'll know that ScyllaDB is written in C++, and we are really proud of that. But whenever users installed ScyllaDB and they saw, hey, you guys have a dependency on Java, that was very confusing, right? So what we did basically was we finally got rid of Java and the JMX dependency. And you can still install JMX and use the Java node tool from Cassandra, but we will eventually sunset support to it, and we recommend that you use ScyllaDB's native implementation going forward. Okay, so quickly going to my terminal again to show you. So node 2 status, as you guys can see, you may think, hey, this is actually the same as Cassandra's, right? But if you actually take a look closer, it's not. It's actually Scylla's. So one of the things, another way you can interact with this node tool is simply by prepending the Scylla ScyllaDB binary name. So Scylla node 2 status, all right? And this works similarly, and it's much faster. All right, so that's something which is super cool. And if you are wondering, hey, what's going on when I run Node2 status? So let's see what's actually the content of Node2. And as you guys can see, it's basically a shell script, which is a wrapper to running the Scylla binary plus Node2 and whatever arguments you guys specify after. All right, so now we can say, yes, ScyllaDB is not only written in C++, but it has no Java dependencies. Super cool, right? So what else, other features we brought? Quickly getting back to the slides here. Some other tooling that was Java dependent was SS table dump and SS table metadata, which were used for if you wanted to inspect the contents of your SS tables. And since Scylla no longer depends on Java, of course, you no longer can use those tools because the ones from Cassandra, they are written in Java. And we did wrote replacement tools for you to interact with your SS tables. And here's the link to our documentation. What is different between our implementation and what you had on Cassandra? So a few interesting things. First, with ScyllaDB SS table, you are now able to know which shard owns a specific SS table. That's something you didn't have. You can run operations such as validate your SS tables, compact your SS tables, and even if you write your SS tables, decompress them, change whatever is written there, and write them back into binary format simply by using our tooling. All right. So I think this is super cool, and it does bring more power to the users, and it's much more oriented with ScyllaDB's architecture. All right. And plus, I mean, you can simply run those operations live with while your node's running. So you can validate and you can scrub SS tables, and that's super cool. All right. Raft API reference. What is this? So ScyllaDB always shipped with Scylla REST API endpoint, where you can simply go and remotely ask for, hey, run a major compaction to this table without having to log into the node, run node2 compact, etc. And one of the things we did right now is we added to our docs, let me show you this, basically API reference, which allows you to basically get quick information over what are the available options. And this is basically this page over here. Simply add the values you want, press enter, and then you guys are going to see the pure command here at the bottom, which you can then use to run on your cluster. All right. So I think this is super helpful to users. Another feature is ScyllaDB maintenance mode. And Lucas, did you ever have a need to, a need to start a node, but isolate that node and prevent it from communicating with others, basically to run maintenance tasks?
Definitely. This is one of the things that our support runs into quite often. And I wouldn't say quite often, but do occur. And basically, we need to perform tasks on the node, but we need to prevent the node to communicate to the other, replicating data, or even getting reads from the others. So, having this option is super helpful.
Yeah. And yeah, so you are now able, I mean, we hope you never have a need to use this option, but if you do, know that it exists. So rather than, oh, let me implement a firewall rule to isolate this node, you don't need to do any of that. You can simply start ScyllaDB in maintenance mode, and from there, you can run whatever maintenance operations you'd like to. So let's do a quick run through to see how it works.
And
So
Felipe,
basically
that is, so sorry to talk over you, but that's particularly helpful when you have a faulty node and you don't want to replace right away. You want to try to save it, initially. So there's a lot of things that you can do on that node. And obviously, if you can sustain, your cluster without that node specifically, but you can run the operations in there and try to recover it before going something more drastic as replacing a node itself.
Yeah, exactly. So maintenance mode, all you have to do is to set this option to ScyllaYAML maintenance mode true, and then you simply go and you restart your node, and then you guys are going to see in the logs that where is it? Maybe it already scrolled through and I lost it, probably. There we go, entering maintenance mode. All right, and then you are going to see that ScyllaDB started in maintenance mode, and from here you can still connect to the cluster, but instead of specifying an IP address or just running CQRS8, you are going to connect to a socket, which is what we open. And from here, you can pretty much run queries local, of course, to this node only. And if you try to run anything remote, such as, for example, node2 status, it doesn't work because this node is not communicating with other replicas. All right. So I think it's a super cool feature, and it helps with maintenance, and it also addresses most users. If you ever have a need to isolate this node and run those kind of operations. All right. So let me go back to the slides. And really quick, mutation fragments. What is this? This is yet another useful tool for debugging and correctness problems. I'm not going to talk too much over here because I see we have less than 10 minutes left. But what you need to know is that this is a tool that allows you to debug performance and or correctness problems, such as, for example, if you suspect you may have data resurrection because you missed a repair window, then you can use this feature And the documentation page over here in the docs actually has a very good walkthrough over how this feature works. Dynamic bloom filters, that's actually a super cool feature, and which we also brought to ScyllaDB recently. And what you need to know is that bloom filters are basically a probabilistic data structure, which all databases, and this is not exclusive to Scylla, all databases rely on in order to optimize I/O access. Okay, one of the problems with bloom filters is that depending on how much data you are storing in a node, they may grow too big. And as bloom filter sizes grow and grow and grow, you may run out of memory. And if you run out of memory, databases have no option but to run out of memory as well. And to prevent that, we introduced this option here, components memory reclaim threshold, which defaults to 20%. And whenever your bloom filters eventually get past this 20% threshold, the database will automatically evict those bloom filters from memory, so that your database never runs out of memory due to bloom filters. Why is this important, Felipe? Why am I actually speaking about bloom filters? Because basically this is a feature which allows ScyllaDB to get beyond the historically recommended memory storage ratio of 1 to 100. All right? Previously, in other releases, we would typically say that if you have 1 gigabyte of memory, you can store up to 100 gigabytes of data. But now with this feature, you no longer need to attain to this particular threshold, all right? So you can scale your cluster even more. Last feature for open source, guys, materialized views and indexes improvements. We introduced a feature which is called synchronous indexes and views, which basically allow updates to your base table to also be done synchronously to your views and indexes. And we also implemented indexing collection columns, all right? So if you have a map and you want to index map keys or values or an entire map entry, you can do that. And also the same for sets and lists, all right? So lots of things. Let's quickly discuss our ScyllaDB Enterprise features, all right? And what you need to know about ScyllaDB Enterprise is that it's even faster, more efficient, and even more secure than open source. So the first thing you need to know is that starting from ScyllaDB 2024.1, ScyllaDB Enterprise users will benefit from better performance and improved latency compared to our open source variants. In case you are wondering, we are not making open source slower. That would be no reason for us to do that. But instead, what we are doing is we are optimizing our enterprise releases as a respect to our paying customers during build time via specific and targeted optimization profiles, all right? So as you can see on those charts, ScyllaDB Enterprise can get up to 1.5x higher throughput while sustaining lower latencies than open source. Therefore, if you currently have an open source deployment, there are high chances that you can save on infrastructure costs simply by switching to our enterprise or cloud offerings, while still counting with our expertise. RPC compression. We also improved internode compression when communicating over the network. So ScyllaDB Enterprise users and also cloud users will observe up to 50% network traffic savings thanks to our usage of compression dictionaries and ZSTD compression. All right? So you guys can see the numbers here on the chart on the right. And if you would like to know more about the technical details behind this specific improvement, Lucas Paskalski will explain how we got there at P99 Conf late in October. All right?
Yeah,
Um,
and one thing in layman's
mhm,
terms, this is like a huge strong point, especially from a customer perspective. When you're a paying customer using Scylla, you still have to pay for networking, and having such a decrease in network costs, it's a huge benefit to, or not only that you're getting faster data being crossed over, but also that you're saving money, which is important.
mhm. And then going even further, I mean, we started this webinar talking about tablets. So is there any benefit specific to ScyllaDB Enterprise users? Of course, there is. We ScyllaDB Enterprise users, and this is an upcoming feature, it's not in any enterprise release yet, they will benefit even more thanks to a feature we called file-based tablet streaming. And remember what we said, tablets are split and they are totally independent from each other. Because of that, we can basically do zero copy streaming without really bothering about their contents. And what this means is that ScyllaDB Enterprise will be able to add and basically do topology changes much faster than ScyllaDB open source. And if you are a Cassandra user, you may probably wonder, hey, Cassandra has a zero copy streaming feature. How is this different than Cassandra's as they introduced it in their version 4? Well, Cassandra implementation only performs zero copy on eligible SS tables. And given that they still rely on the vnode replication architecture, this is rarely the case. When an SS table is not eligible, then Cassandra will fall back to legacy streaming logic. ScyllaDB Enterprise with tablets, on the other hand, always performs file-based streaming. All right, so you always get zero copy streaming no matter what. And finally, the last important item, because this is important for our enterprise users, is security. ScyllaDB Cloud and enterprise users will now benefit with Amazon KMS integration, transparent data encryption, which encrypts all system resources. They are now able to authenticate against their database using TLS certificates, and we now ship ScyllaDB Enterprise images and container images, which are FIPS compliant. All right? And on top of that, ScyllaDB Cloud is also PCI DSS compliant. So if you have a hard requirement of processing payment card industry data, ScyllaDB Cloud is also now able to support those types of workloads. All right? So this is pretty much what Lucas and I had to talk, a lot of features, and this brings us to the last poll of our day. Which database do you guys currently use in production? Please let us know so we can better adapt our content. And before we wrap up, guys, please keep on learning. A few resources here on the screen for you. First, visit our blog if you want to know deeper about those features we just spoke about today. Remember that late in October, we'll be hosting P99Conf, which is a virtual event for engineers and done by engineers. And you are going to find companies like Meta, Red Hat, Netflix, Uber, AWS, and more. And later this month, we will have ScyllaDB University Live for those of you interested in getting your first touch with ScyllaDB. All right? So, Lucas, thank you so much for joining me here today. We are going to follow up with you guys via email because we didn't have the chance to address any questions. Sorry about that. But yeah, thank you so much, guys, and we wish you a great day ahead.
Thank you for joining.